In the previous video, we have discussed about the atomistic approach and one electron approach. So, before going to study about the band theory, we have to discuss about Bloch theorem. See, in one electron approximation, we have considered the electrons are moving through the gap between positive ions. So let us consider these positive ions are placed at regular intervals, that is with the periodicity is equal to A. That is here A, this is A, this is A, and so on. Right. See, when you consider it, see, when the electron is moving through the gap between the positive ions, right? See, the potential versus distance, we can write the diagram or the graph. Right. Here you have the positive ions. H. So this is A, whatever may be. So when the electron reaches nearer to positive ion, right, its potential is decreased. When it is in between, its potential is increased. This is the meaning of this diagram. Here, that means electrons are moving. So that means, see, if the energy of the electron which is here, that if I am writing this one as E1, if it is travels a distance is equal to A, then here also its energy is E1. See, the energy of this electron here is E2. If it is travels a distance is equal to A, then its energy is E2. That is what you are saying, with the periodicity is A. That is, at regular intervals, the energy of the electron remains same. See, this Bloch theorem is actually there is no statement. It is only the mathematical statement regarding the form of one electron wave function. Electron is a material particle. Therefore, the motion of the electron can be described in terms of wave function. So just, right? So, here we are considering the electron wave function for a perfectly periodic potential well. Just I have explained in the diagram. So, to understand the motion of electron in this potential, as you know, we have to solve the Schrodinger's wave equation. That is d square xi by dx square plus 2m by h cut square into e minus v of x into xi of x is equal to 0. This is the equation number 1. According to Bloch, if the electron is moving in a periodic potential with the periodicity is A, then this Schrodinger equation is having the solution of the form xi of x is equal to e to the power plus or minus ikx into uk of x. So that is what it says. If the electron is moving in a periodic potential, then the solution of the Schrodinger equation is in this form. This mathematical statement is considered to be Bloch theorem. Now our aim is to prove the statement of this Bloch theorem is correct. That is, we have to prove now the solution of this Schrodinger equation is having this form. Okay. Now, as you observing, Schrodinger equation is a second order differential equation. Therefore, it has two independent solutions. It has two independent solutions. Let us you take these two independent solutions as f of x and g of x. So, now then what happens? The solution of the equation can be written as constant a into f of x plus another constant b into g of x. Right. Okay. Now, let us we take this one as 1. Okay. Now, here a and b are arbitrary constant. As we told, the potential of the electron, right, it is a periodic potential where the periodicity is A. That means if it is plus, right? So that means, let us you consider at this distance the potential of the electron is V at a distance of x from a reference. If it is travels a distance is equal to a, I am writing the potential of the electron is V of x plus a. But it has periodic potential, well, means at regular intervals it has the same potential. That means V of x plus a is equal to V of x. This is equation number 2. You have to note down because afterwards I will erase this. So note down the equations, and similarly as I rubbed it, when I asked you to refer the equation number, you have to in your book refer it. So now that means if f of x and g of x are the two independent solutions, whether these are only the solutions to this Schrodinger equation, the answer is no, because V of x plus a is V of x. That means what? If f of x is an one independent solution, then what happens? F of x plus a is also one solution. If g of x is one independent solution, then also you can say that g of x plus a also independent solutions. Therefore, if f of x and g of x are the two independent solutions, due to periodicity, f of x plus a and g of x plus a are also two independent solutions. That means you can say f of x plus a is equal to f of x, right? But I am not writing like this. Now I am writing f of x plus a. This one in terms of the combination of f of x and g of x. That means what? F of x plus a is equal to some constant alpha 1 into f of x plus alpha 2 into g of x. Similarly, g of x plus a is equal to beta 1 into f of x plus beta 2 into g of x. Right. Call this one as equation number 3. Okay. So, here alpha 1, alpha 2, beta 1, beta 2, these are all real constants. Okay. Now, we can write the solution xi of x plus a is equal to, see, xi of, use the equation 1. Xi of x is a into this. If what I did, x is replaced by x plus a. That's all. Wherever x is present, replace it with the x plus a. A into f of x plus a plus b into g of x plus a. Now what you have to do? You have to, from equation number 3, you substitute it for f of x plus a and g of x plus a. That is a into alpha 1 f of x plus alpha 2 into g of x plus b into beta 1 into f of x plus beta 2 into g of x. Okay, now you collect the terms containing f of x first, then collect the terms containing g of x next. So when you perform this, what happens? A into alpha 1 plus b into beta 1 into f of x plus a into alpha 2 plus b into beta 2 into g of x. So now what I am doing is I am introducing a constant, a lambda. I am writing this product is equal to lambda a. Okay, product and sum. This term, this is equal to lambda b. Okay. So therefore what happens then? Xi of x plus a is equal to, lambda is common, right? You can take outside. So lambda into a into f of x plus b into g of x. This is equal to lambda into xi of x, right, using equation number 1. So this is the equation 4. So xi of x plus a is equal to lambda, so into xi of x, that is the equation number 4. Okay. Now that is what we have just before the equation number 4, what we have taken, a into alpha 1 plus b into beta 1 is equal to lambda a. Similarly, a into alpha 2 plus b into beta 2 is equal to lambda b. Now you rearrange this equation, bring lambda a to the left hand side, and in the equation second bring lambda 2 to the left hand side. Then what happens? The first equation becomes, a is common term, so it becomes alpha 1 minus lambda into a plus beta 1 into b is equal to 0. Similarly, the second equation, alpha 2 into A plus beta 2 minus lambda into B is equal to 0. Now, this is linear equation. Here, for solutions other than A is equal to B is equal to 0, that means what? For non-vanishing solutions for A and B, what we have to do? What is the condition? The condition for non-vanishing solutions of A and B is non-vanishing solutions A and B is the coefficients of A and B whose determinant is equal to 0. That means alpha 1 minus lambda. Here you have to write beta 1, write down the coefficients in determinant. Beta 2 minus lambda, this should be equal to 0. So that what happens now? In this case, you have to simplify it, this determinant. Then finally, after simplification, in your notes, you have to write down the simplified step. But here I will directly write it. You simplify and check whether you are getting the same answer. After simplification, lambda square minus alpha 1 plus beta 2 into lambda plus alpha 1 beta 2 minus alpha 2 beta 1, this is equal to 0. This is equation number 5. Okay. So since f of x and g of x are two independent solutions of the Schrodinger's wave equation, therefore what we can write, we can replace xi of x by g of x. Similarly, we can replace xi of x by f of x, and we can write down the Schrodinger's wave equation. So now in the Schrodinger's wave equation, I am replacing xi of x by g of x first, because it is an independent solution. D square g of x of dx square plus 2m by h cut square into e minus v of x into g of x is equal to 0. Similarly, d square f of x by dx square plus 2m by h cut square into e minus v of x to f of x is equal to 0. In the next step, what you have to do is, for this equation, you have to multiply both sides by f of x. Similarly, for second equation, you have to multiply both sides by g of x. After multiplication, you have to subtract the two equation. Subtract. What you will get? See, this is multiplied with f of x. This minus this. This is multiplied with g of x. That means you are getting now f of x into d square g of x by dx square minus g of x into d square f of x by dx square. But when you multiply, it becomes g of x, f of x, it becomes f of x, this get cancelled and it becomes 0. When you integrate this, you will get f of x is equal to d by dx of g of x minus g of x d by dx of f of x. This is equal to constant. Right. So this f of x into this d by dx of g of x minus g of x into d by dx. This is called Wronskian. See, Wronskian is used in differential calculus in order to prove that the solutions are two independent solutions. If solutions are independent, then Wronskian becomes a constant. This is the equation number 6. Okay, now I am representing this Wronskian as w of x. This one as w of x. Remember, w of x is nothing but f of x d by dx of g of x minus g of x d by dx of f of x. This is nothing but Wronskian. Okay, now what we have to do in the next step, right? If f of x is one independent solution, then f of x plus a is also an independent solution. Similarly, if g of x is the solution, g of x plus a is also a solution. Therefore, by looking into, I am just replacing x by x plus a in this expression. F of x plus a into d by dx of g of x plus a minus g of x plus a into d by dx of f of x plus a. What you have to do now? See, this is equal to, now this is the homework for you. What you have to do is, now you use your equation number 3, where you have the expression for f of x plus a as alpha 1 into f of x plus alpha 2 into g of x. Similarly, g of x plus a is equal to beta 1 into f of x plus beta 2 into g of x. So, in this place, you have to replace f of x plus a and g of x plus a. Its value is replaced by using equation number 3. Then you have to simplify. After simplification, you will get the answer as alpha 1. This one you have to work out. Remember, don't directly write. Alpha 1 beta 2 minus alpha 2 beta 1 into f of x into d by dx of g of x minus g of x into d by dx of f of x. So that means this I can write. See, this one is the Wronskian, right? So, but just in the Wronskian I have replaced x by x plus a. Therefore, I can write this one as w of x plus a. This is equal to alpha 1 beta 2 minus alpha 2 beta 1 into w of x, Wronskian. Since as we have considered the periodic potential well, therefore to get the periodicity concept, the solutions are periodic only if w of x plus a is equal to w of x. It is possible only when alpha 1 beta 2 minus alpha 2 beta 1, this is equal to 1. Therefore, what happens, the equation number 5? See, equation number 5, you refer, observe in your notebook now. It says lambda square minus alpha 1 plus beta 2 into lambda plus you have what? Alpha 1 beta 2 minus alpha 2 beta 1. According to now, this is equal to 1. this is equal to 0. So, now this is a quadratic equation. So, that is in the form ax square plus bx plus c is equal to 0. Then x is equal to minus b plus or minus square root of b square minus 4ac by 2a. You well know. That means what? X has two solutions. In the place of x you have lambda. That means two roots are possible. Two roots are possible. So, let us you take the solutions of this equation is, that is, roots are lambda 1 and lambda 2. Right? Lambda 1 and lambda 2. So, if there are two solutions, then there will be corresponding to two solutions, we are having two wave functions, xi1 and xi2. One wave function corresponding to lambda 1, one other one, that is xi2, corresponding to lambda 2. Okay. So now, using this, let us consider two cases. One, let us use, there are two solutions as already mentioned, lambda 1 and lambda 2. Consider a situation such that lambda 1 into lambda 2 is equal to 1. When it is possible, that means if you take, say, lambda 1 is equal to e to the power plus I ka, to get product equal to 1, lambda 2 should be e to the power minus I ka. Now you write xi1 of x plus a. So, as you know, remember this, in the beginning we have written xi of x plus a is equal to lambda of xi of x. Remember this. Using this, I am writing the first solution. xi1 of x plus a is equal to lambda. Lambda is lambda 1 e to the power I ka into xi1 of x. Similarly, xi2 of x plus a is equal to e to the power minus I ka into xi2 of x. So in general, you can write xi of x plus a is equal to e to the power plus or minus I ka into xi of x. So therefore, what is this actually? This is the solution we have obtained by solving the Schrodinger's wave equation. See, this is according to our theory. But what Bloch stated, according to Bloch, the solution of the Schrodinger equation we have considered with the periodicity is equal to a is xi of x is equal to e to the power plus or minus I kx into uk of x. That means, let us prove now this equation is correct. How we can prove this equation is true? Because by solving the Schrodinger equation we have obtained this solution. Let us see, using this relation, can we obtain the same solution? That one we have to see. So now consider xi of x plus a is equal to e to the power plus or minus I k x plus a into uk of x plus a. This is equal to you can write e to the power plus or minus ikx into e to the power plus or minus ika into uk of x. I am writing. Why? Since it is the periodic potential, uk of x is equal to uk of x plus a. So therefore this is equal to, I am taking now uk of x into e to the power plus or minus ikx as xi of x. Now I am writing this one first here. So that is e to the power plus or minus ika into this into this I am taking as xi of x, because any wave function is written as xi is equal to something a into e to the power we are writing. So in the place of a, what you have? You have e to the power plus or minus ikx. This is taken as xi of x. So therefore this, what is this plus or minus? This is nothing but lambda, right? This is nothing but lambda. So xi of x. So xi of x plus a is equal to lambda into xi x. That is what we have started our discussion, right? Xi of x plus a is equal to lambda into xi of x. Same result we are obtaining using the Bloch statement. Therefore the Bloch theorem is true. This is the first case. We have considered the imaginary number. Second, you consider the constants lambda 1 and lambda 2 are real. What happens? Right? Second case, can we consider? So, let us you consider the real roots instead of imaginary. So, lambda 1 is equal to e to the power mu x. Lambda 2 is equal to e to the power minus mu x. Mu x or, it is, say, constant, periodicity, let us say, x is equal to a. E to the power mu a and e to the power minus mu a. That is, xi 1 of x is equal to e to the power mu a into uk of x, or simply you can write u of x, because not imaginary, so k won't come. Xi 2 of x is equal to e to the power minus mu a into u of x. The question is, can we prove this Bloch theorem using this? No. If you consider the real roots, we cannot. Why we are not able to consider the real roots? For this you have to remember the quantum mechanics, where you have studied the properties of wave function, acceptable wave functions and non-acceptable wave functions. See, as you know, wave functions are acceptable, it should be single valued, continuous, and it should be finite everywhere, right? Now you just consider here, say, when you consider to this, okay, say for example, if a tends to infinity, what happens? Or a is equal to x, okay, x is equal to infinity, here also a is equal to x, a is equal to x tending to minus infinity. What happens here? Right? See, when x tend to infinity, e to the power infinity you are getting, that is xi 1 tends to infinity. When x tends to minus infinity, xi 2 tends to infinity. That means it is not finite. It tends to infinity. Therefore, it is not a acceptable wave function. So this is about the Bloch theorem and its proof. In our next lecture, we will discuss about nearly free electron theory, where we will use this Bloch theorem Therefore, everyone should read this Bloch theorem and understand it properly. And if you have any doubts, you can ask the questions through WhatsApp or by calling personally. Okay, thank you.